Okay, in this video I'm going to show you how to use Desmos to do the regression problems. So there's a link in your assignment and you're going to click on that, and it's actually like a tour, so it's going to kind of guide us through it. You can get sample data, but we're going to add our own data. So click on the plus button, and that lets you add things, and what we want to add is a table. Now you're going to do a problem. You're going to add the data from your problem. And this is one of the problems on your assignment. I don't remember what number it is, but it's the first one where you have to find the model. I think it's number 4. And it's a physics problem, and it says that there is an approximate number of degrees Fahrenheit above room temperature of a cup of tea as it cools. Find an exponential model for the data. And then you're supposed to answer some questions. So we're going to use our time as our x values, and our first coordinate is at 0 minutes, the temperature is 132, and this is from your problem, and then you can just keep going down the row. And this is going to plot some points for us. And then at 1 minute, the temp is 120, and at 2 minutes, the temp is 110, and so on. At 3 minutes, we are at 101. And at 4 minutes, it's 93. Okay, that's all the data I need. Now, I'm going to check and see if this data is exponential, linear, quadratic, or whatever. So, the next step on my little tour here, and select the expression. So now I need to, that's why I like this tour, because it tells me what to do next. So I'm going to select the expression one instead of the table. And now they're giving me how to do it for linear. This is y equals mx plus b. But we don't want linear because we're not in Algebra 1. We're not doing the linear section. It says to get y1, just type y with a 1 after it. I'm just typing on my keyboard. And then the similar thing is on our on-screen keypad. Oh, I have to click ABC. Let me move this so that you can see it. I have it maximized and you can't see the bottom. Okay. I think you can see it now. So I have to click ABC, and then I have to find this. There's the similar button. And I don't want mx of 1 plus b. What I want is a, and then times, I have to go back to the times b to the x, b, and then to the x power. Move this box. I'm not done. The box is in my way. To the x power. And it's not supposed to be x, it's supposed to be x1 after it. Okay? So I don't want to click log mode. So what it's telling me right away, even though I haven't yet set my graph to see these points, is that this model is really good. Let me change my graph right now so that I can see my points. Right now my grid only shows from 0 to 10, or negative 10 to 10 on the x, and from 0 or negative 4 to 4 on the y. I need to see more on the y. Because look at my points went all the way up to 132. So my y-axis, negative 5 is fine, to like, I'll go to 150. And my x-axis only needs to go to from 0, really, because we're only looking at the positive values, to 10 is fine. Okay, so let's look now. I'm going to zoom out a little bit. Okay, now I can see those points? Let me turn this function off. That's the points, that's after the table. That's after we entered all those points. And then when I turned this on, this is when I added an expression, it's showing that this kind of orange colored curve, that's the exponential function, with a 131.52 and b 0.91597. That's what you would replace a and b with. You wouldn't replace x with anything, and you wouldn't replace y with anything, because that's part of the equation. So let me add another. I'm going to write y equals A is 131.52 times B is 0.91597 to the x power. That line is the same as the orange line. A up here is the 131 that it calculated for you, and B is the 0.91597 that it calculated for you. And the r squared, the closer that is to 1, the better this curve, this exponential function, this model fits the data. So this is really, really good fit. So if I don't have that on, that's the orange line that the program calculated for us, and the black line is, that's what you would answer for your homework. That's what you would say the exponential function model for this problem is. And that's how you will use this. Now there's another model if we wanted to do a logarithm function for another problem. I wonder if I should just start over. I'm going to leave the page. Okay, so now we're going to, again, click the plus sign. And this problem is some population for a small town following its incorporation. And we're trying to find a natural log model. So I need a table. And the data, which will be in your problem, I don't remember exactly what number this is, like 6 or 7. And here's our data. This is time in months after this event happened. And we're starting at 6. And at that time, the population was 3,000. And then, really conveniently, in 18 months, the population was 4,000. And in 42 months, the population was a nice even 5,000. And then in 90 months, it was 6,000. And this is our last one, in 150 months, this was 7,000. Okay, now we are going to click to add an expression. Now again, they're telling us to add a linear expression. I think before I do this, I'm going to change my settings because y is so super big right now that I want to actually see where my points are. So I'm going to go all the way up to 8,000. And oh, I did x instead of y. I don't need that. My y-axis needs to go to like 8,000. There. And I'm going to zoom out a little bit so I can see my axes. Now, do you see the points? Oh, my x-axis has to go from 6 to 150, so I do need more on my x-axis. Up to, I'll go to 160, so I can see all of them. And I'm going to zoom out so I can see my grid better. Okay, so there we go. Now, let's say that we thought that this would be exponential like our last one. So do you remember that? It was y1, and then is similar to, that was in the ABC part. And we wanted to see, is this close to what an exponential, would the exponential model fit this data? And you could try linear too, the one that's up there. And times, and it was b to the x power x. And we have to x1. Okay, so that's how it fits it. Not super good. The points, there's one on the line, but a lot of them will be above and below. And also look here, the r squared function point is only 0.88, so that shows that it's not very good. It's not as close to 1 as our last one was 0.99. All right, let's try a different one. And you could leave that on there so you could check and see. Maybe that'll be the best one we can find. So we're going to do y1, and then we're going to do that similar button again. And this time we're going to try a times, oh no, sorry, a plus, whoops, my a plus b times the natural log. I have to do the times sign though. And then for natural log, you can just type ln, and then we need our x. And we don't need x, you need x1 after it. Okay, so this is the natural log model. And you can see that it is fitting the data better. It's not perfect, but at least it's following the curve of the data. And this one has an r squared value of 0.98. 0.83, which is a lot better than 0.88. So I would say that this fits the natural log model better than the exponential model. You could even do this again with linear, and linear actually fits better than the exponential, but I won't do it right now. And again, to check this, or to show what you would turn in for your answer, it would be y equals, okay, A is the 621.55, and then it was plus, and then the natural log of, oh, I forgot the B. B was 1221, and then times natural log of x, right? Okay, got everything. And now you see it turned red because this is actually traced right over top of it. Model fits pretty good. Not perfect, but data rarely is perfectly fitting a model. And that's all you'd have to do for the natural log one. So I really like the way Desmos does this. You have to know the general form of the exponential and the logarithmic, but I'll type those in to the assignment for you, and you can decide which model fits better, and then you can write the equation that would model the data. All right, thank you very much. Have a great day.